Okay, let's look at 2.1 basic functions and their graphs. So a relation is a set of ordered pairs. Domain, or D, is the set of all first components of an ordered pair in the relation. Okay, so that's your X's. And the range, or R, is the set of the second components in the relation. So that's your Y's. And a relation is X comma Y. Okay? A function is a correspondence from the first set, called the domain, to the second set, called the range, such that each element of the domain corresponds exactly one element of the range. So in other words, a function is a special kind of relation that pairs each element from the domain with one and only one element from the range. I'm going to say this as many ways as I can so that you guys understand. For every X, there's exactly one Y. Okay? And the first coordinate appears only once. I have quirky ways of remembering things. You guys are going to see that more and more throughout this semester, and I'm going to draw you a picture that one of my professors drew for me and kind of made it click in my head. So whenever I think of a function, I think of a mailman. So here we go. Think about a mailman. He delivers letters to mailboxes. Letter can only go to one mailbox. So a letter can only go to one mailbox. So here we have, not an artist by any means, mailman. And our mailman is our function. And here are our letters. I don't have to wonder why I didn't major in art, right? So these are our X's. And then here are our mailboxes. These are our Y's. So each of these letters can only go to one mailbox. This letter, I want a different color. This letter can only go to this mailbox, right? He can't go to two mailboxes. He can only go to one. So he can only go to this mailbox. And this letter can only go to one mailbox. So he can only, say, go to this mailbox. And this letter can only go to one mailbox. Now, a mailbox can take two letters, but a letter can't go to two mailboxes. So it's the same concept when you have a function, right? Your X's can only go to one Y. Okay, same idea. So whenever you get hung up and can't remember, just think about like the mailman can only deliver a letter to one mailbox. So your X's can only go to one Y. Okay. And there's probably the most expensive picture you've ever bought. Just think about your tuition, huh? Okay. So although every function is by definition a relation, not every relation is a function, and that's very important to remember. Now let's determine whether each relation is a function. So remember, to be a function, your X cannot be repeated, okay? So that's how we're going to decide this. So our domain. Remember, our domain is our X's, okay? So domain is the x's. So what is our domain here? Our domain is 1, 2, 3, and 4. And our range. Let's look at our range. Our range. I'll mark this over here. This is our x's. And our range is our y's. Probably help us. Now our range is 6, 6, 8, and 9. And you do not have to write them down if they repeat, but I'm just writing it so you can see the repetition now, okay? So is this a function? It is a function. And it's a function because no x's repeat. Okay? And it's okay for these to repeat because this is your range, so no worries. Now let's look at this one. Let's look at our domain here. We have a 6, a 6, an 8, and a 9. Right? These are our x's. So is this a function? Absolutely not. In function, that's my shorthand, okay? And this is because x's repeat. That's no good, okay? Now our range here, which is our y's, 1, 2, 3, and 4. Okay? So this is not a function because these two repeat. We can never have x's repeat and it be a function. Okay. So functions as equations. Functions are usually given in terms of equations rather than sets of ordered pairs. So this is rare that we see this, okay? So it is important to know the difference between independent and dependent variables. The function of x, which tells us that for each x, there is one and only one y. Therefore, the variable x is called the independent. Okay? Independent variable because it can be assigned any value. Like we can assign any value to x. But the variable y is called the dependent variable because what it becomes is strictly dependent on what x is, the value x is given. Okay, that's why it is called the dependent variable. So y is always our dependent because what he becomes depends on what amount we set x to be. Just like every ordered pair is not a function, every equation is not a function, okay? If the exponent for y in any equation contains an even power, this is super important, this is like a great tip. If the exponent for y contains an even power, then the equation does not define as a function, okay? So like if it's y squared or y to the fourth, it is not going to be a function. Like this is a super, I'm going to put, this always means to remember or it's important. So this is like super duper important. Okay? It's a good tip. All right. And now, since I just stated this, I'm not going to expect you to believe me. I'm going to show you why that is so. Paper to stay over here. Okay. So now we're going to determine if the equation is a function. So to do this, we always solve for y. So let's do that over here on the first one. To solve for y, we're going to subtract our x squared. And what you do on one side, you have to do on the other. Okay? So then y equals 4 minus x squared. So now we can see that y is going to depend on what x is, the value that x, right? We pick for x. So let's let x equal 1, okay? So if we say y equals 4 minus 1 squared. So that's going to be 4 minus 1. So 4 minus 1 is 3. So then y equals 3. So for when x equals 1, y is 3. So that would be our ordered pair there, okay? So now let's do the same thing over here. So this one would be a function. I'm going to write that in a different color. So this one is a function. Now let's solve this one over here. Same thing. We're solving for y, so we're going to subtract x squared from both sides. So we have y squared equals 4 minus x squared. Okay. Well, remember, how do we get rid of a square? We always take the square root. What you do to one side, you must do to the other. But it's an even root, so you have to remember plus minus. So we're going to have y equals plus minus square root of 4 minus x squared. Okay? So we already see that we're going to get two answers, right? So that automatically tells us that that's not 1. So it's not a function, but we're going to go ahead and keep going. So let's choose x 0 here, okay? So we're going to have y equals plus minus square root of 4 minus 0 squared. Well, 0 squared is just 0, so this is going to equal plus minus square root of 4. Square root of 4 is what? 2. So then y equals a negative 2 and a positive 2. So we'll make a little xy chart. So our x equals 0, right? But then our y is going to equal two numbers. For our 0, y is going to equal negative 2 and positive 2. And we just learned on the other that one x can't go to two y's. So this is why it's not a function. Because it breaks the function rule. Okay, so that explains why if it has a square or even any even power, it's not a function. Okay. So function notation can be used to find the y values that correspond to any chosen x values, forming ordered pairs that satisfy the function rule, make the function true, and on the graph of and lie on the graph of a function. Sorry. In function notation, instead of writing y, for example, we write f of x. Okay, and it's read, well, like I just said it, f of x or f at x. I will never say f at x. I will always say f of x. That's just what I've always heard, what I've always been taught. This is foreign to me, so I will not say it. So f of x represents the value of the function at the number x. That is, the notation f of x represents the y value for some corresponding x value. But keep in mind, the function does not always have to be named f. It could be named g, h, it could be capital F, capital G, or capital H. So for those of you who go on to higher math, like calculus, trig, differential, things like that, you'll see more and more of the capital G and capital H and capital F when you take derivatives and integrals, things like that. So that'll come into play in higher math, okay? All right. Let's see how this works with an equation. So let's work this equation. So, have y equals 0.012 x squared minus 0.2x plus 8.7, okay? So the first thing that we're going to do, x is our input, and y equals f of x. So instead of y, we're going to change this to f of x. That's our first step. So we're going to say f of x equals 0.012 x squared minus 0.2x plus 8. So now we have y equals f of x. Now we want to evaluate it at what this tells us our x equals. So I'm going to change colors now. Now you evaluate at x equals 30. So everywhere there's an x, we're going to plug 30 in for that x, including here. So we're going to say f of 30 equals 0.012. Put 30 here in parentheses, always in parentheses when we plug something in for x, okay? Squared minus 0.2 times 30 plus 8.7. Okay, so what we did here in this step is we plugged 30 in for x. That's what we did. So now let's just go ahead and kind of work this out. 0.012, 30 squared is 900. I'm just going to write this out for notes. You can go ahead and do the math if you want to. But I'm note building, so we want to do every step so everybody has that if they need it. So 0.012 times 600 gives us 10.8 minus 6 plus 8.7. And then that is going to simplify down to 13.5. And that's what our f of 30 equals. Okay? Now, we can do this on the calculator. So let's do that so you can see how to do it on the calculator as well. And I'm going to try to do it to where you can see both the instructions and the calculator, and I think that's going to be maybe absolutely impossible. So anyway, hopefully instructions and you can see both. Maybe if I do this. Hold on a second. Okay, so first thing we're going to do is we're going to hit y equals, and we're going to enter our function. So 0.012 x squared. I'll slow down. Sorry. Minus 0.2 x. Ooh, hang on. Throw out of that. Minus 0.2 x plus 8.7. Don't do what I just did. Do not leave it up in the exponent line. That's terrible. Okay, so now we have all of that in there, and we're going to second table set, which is above window, okay? Let me go back down where I'm supposed to be. There we go. When you get here, we want table start at 0, okay? We always want it to table by 1 because we want it to go up 1 increment. That's just where it needs to be set. We're going to arrow down right here. It's at auto. We don't want it to be at auto. We want it to be at ask. So arrow over to ask and then hit enter. Okay? So once it is at ask, now when we go into our table, second table, it's going to say x equals. And then we could tell it that we want it to be 30 because remember up here, we wanted our x to be 30. So that's why we're going to say here, enter 30. So 30 is what we're going to enter here. And then we hit enter. And it should give us the exact same amount that we got up here. So that's how you can use your calculator to work a problem like this. A lot faster, right? So now you know how to do it by hand and you know how to do it by calculator. Okay? So here's the steps if you need them to practice it. Okay? All right. Oh, and to get out of that mode, let's see. So you're in this. To get out of that, just hit second and then mode, and that second quit, and it'll take you out of that, and then you're back into your normal calculator screen. Okay? Right on. Okay. Practice a couple of these. I'm going to do them by hand. You can do them by calculator if you wish. That way you can have we're working by hand now, and you could practice calculator later or whatever you want to do. So do A first. So we're going to plug 2 in for all of the x's. So we're going to do f of 2, which is going to equal 2 squared plus 3 times 2 plus 5. 2 squared is 4, plus 6 plus 5. That gives us 15. Okay? Not too bad, right? B. So we have f of x plus 3. Put everything in parentheses, so x plus 3 squared plus 3 times x plus 3 plus 5. One of the top mistakes in college algebra is just to take this square in. That is not what a square means. A square means this quantity squared. So we're going to step over here and we're going to FOIL that, okay? X plus 3 times x plus 3. You guys remember how to FOIL? X times x, x squared. X times positive 3, 3x. 3 times x, 3x. 3 times 3, 9. Now you combine these two like terms, you get x squared plus 6x plus 9. That is what x plus 3 squared equals, okay? That's what x plus 3 squared, okay? This is our little scratch. Always do your scratcher to the side. Then once you find your answer, you plug it back in neatly, okay? You don't do your scratch work in the middle of your problem, ever. That is such bad form, okay? So we're going to have x squared plus 6x plus 9. That's all in place of this. Here we're going to distribute this 3 in, okay? 3 times x, 3x, 3 times 3, plus 9. And then we'll have 5. Now we're going to combine like terms. Let's do that. We just have 1x squared, but we have a 6x and a 3x. So that's going to be 9x. And then we have, I'm going to put this on top, we have a 9 and we have a 5. Oh, and we have another 9, 23. Got that one 9. So this is going to be our answer for B. Now let's do C. It's going to be f of negative x. Remember parenthesis, negative x squared plus 3 times negative x plus 5. Negative x squared, that's the same thing as saying negative x times negative x. A negative times a negative gives you a positive. And when you have your exponents up here, you add those. So it's going to be 1, 2, x squared. So this is going to turn into x squared minus 3x plus 5. And we're done with that one. Okay? All right. Okay, that's the end of this one. We'll pick back up with the second one in just a moment.